And welcome everybody to our meteorology segment. We're starting out looking at the NASA GOES lightning mapper here to see some continued lightning here over central Texas. There is an air mass, a massive dry mass of air up here around Oklahoma, which all this moisture at Texas is plowing into, causing it to stagnate in the state of Texas. We'll show you more on that in a moment. So here's a real-time lightning map, rather. Not a real-time lightning map. We've got some significant lightning here around San Angelo, just north of El Dorado, Texas. We see quite an active thunderstorm there. And we'll zoom out to the global view here. That's lightningmaps.org, by the way. Next time you hear thunder, you may want to check it out. We've also got some lightning here in the Nashville region, in between Nashville and Chattanooga. Seeing some active thunderstorms there. Near Lynchburg and Lewisburg. And there's your global lightning map. Here are the jet streams of the Western world. And you can see how chaotic these jet streams are over the U.S. Very chaotic jet stream flows right here. A highly incoherent and meridional jet stream flow, featuring a 180-degree bend here south of Lake Michigan and around Baja California. Also doubled up jet stream, tripled up jet stream over the North Atlantic. Southern Hemisphere a little more coherent. Here are the surface winds. Powerful low pressure system here southeast of Greenland, as you can see on the surface wind map, as well as southeast of South America. And you can see the opposite rotation of that. Clockwise in the southern hemisphere, counterclockwise in the northern hemisphere for low pressure systems. Here are the surface winds of the eastern world. And there are the jet streams, probably the most comprehensive worldwide weather piece of data you could get. And we've got the jet stream blowing backwards here over the western Pacific. Places like the Philippines are seeing a backwards flowing jet stream flowing east to west instead of the normal west to east fashion. Next, let's talk about contrails and cirrus clouds. So this image here, it shows you a bunch of wispy clouds. These look like stratocirrus clouds as they appear to be at a fairly low altitude. You can see some indication of their distance here because of these cumulus clouds. Some of these look like they're in the foreground. They're probably stratocirrus clouds, which are quite common around airports. You can see one contrail there in the background. Check out this idiotic article. It's a sharticle from phys.org. Less aviation during the global lockdown had a, quote, positive impact, end quote, on the climate. What the article is stating is that clouds cause global warming. So that's the moronic idea asserted by this article. And while clouds do make the planet warmer at nighttime, the albedo effect of the clouds cools the planet in the daytime. So you get lower highs and higher lows as a result of more cloudy environment. And of course, the airspace around an airport is going to be rather cloudy as a result of all of the contrails. We can see massive cloud banks forming if the atmospheric conditions are just right, just as a result of a plane flying through the area. It can, in other words, one contrail can theoretically cloud up the entire sky. So the idea that we need a colder planet is just ridiculous in the first place. The idea that the planet is warming is just ridiculous in the first place. If you've cherry-picked data from 1979, you may be able to figure out a way to make it look like it was warming. If you knew anything about the geologic record, and you looked at the temperatures since the Minoan warm period, the planet has been cooling for the past 6,000 years. And anyway, if you'd like to read that article, it is on phys.org in the Earth section, which is full of sharticles. Today's about the idea that, oh noes, the planet's warming and less flights caused it to be less warm. Anyway, I won't dwell on that. Next, looking at pressure cells here, and we see low pressure around the whole planet. Really, I mean, we see a disparity here. Excessive amounts of low pressure and small amounts of high pressure, really. Anyway, that's the current pressure environment. Let's switch this to the European forecast. We're going to move this forward till tomorrow. There's where we expect pressure to be according to the European forecast at 1 p.m. Eastern Daylight Time tomorrow. That's windy.com, by the way. They've got a great mobile app as well, and I'm not yet paid to tell you this. And here's the U.S. Doppler radar map. And again, what we've got is we've got some dry massive air here, which is preventing this moisture from being able to escape Texas. We'll show you in a minute. Here's the cloud layer, and you can see this clear spot right here. That's that dry massive air I was talking about. It will be very evident in the water vapor map. There you can see that strip of dry air there. And the jet stream is making this crazy bend like this. And that dry massive air right there over Oklahoma is a high pressure system, relatively speaking, and it is causing that moisture to stagnate in Texas. If you're wondering what's causing it, that's what's causing it. Again, there's the cloud layer. And we're using the NASA GOES Interactive Weather Satellite 3.9 nanometer shortwave radiation map to see clouds at nighttime when it's too dark to see them with a visible satellite. So here's a recap. There's the U.S. Doppler radar map. There is the cloud layer scenario. And here's the water vapor map. That should help give you some insight. And that's today's meteorology segment. Thanks for tuning in. I've been your host, Dan, a.k.a. smAsho, signing off from here at the Smash News Network. Least busted, name in news.